Hey, my computer wasn't recording the microphone audio, so I'm just going to interject when there's a point to be spoken about and just record a voiceover watching with you. That way I'm not making another project and muddying up our class repository. Here I'm just showing the different scalability settings, and that if you have a beefy PC, you can go to Epic settings if you want, but if you're working from a laptop, I would suggest going from the low settings, and things will have a little bit more jagged edges. The shadows won't be as pronounced or clear, but at least it gets you with a more performative software interface. Alright, so that's the list of the things we're going to do in the tutorial today. We've already done a few during the regular class discussion. Some of the first few we've already done. So here's where I should have been checking that red X is through the speaker on the OBS. So open broadcast recorder. But here we go. Here's our project. And let's do some interactivity. And when I re-edit this video, I'll put it in the Dropbox and call it like week 2, a version 2 or something like that. So if you don't want to listen to my bad voiceover and you just want to watch the video with having to listen to it, you'll be fine. You'll have both. So we're going to talk about collisions first. And the important concept here is that it's not the geometry that is colliding with each other. It's an invisible layer geometry that's much simplified so that it has less polygons, therefore it has to calculate a lot less collisions. Oftentimes, these different geometries are significantly reduced, and therefore it makes it easier to analyze. And what I was just doing was looking at the static mesh editor, where you can preview collisions. And if the collision is removed from an object, it will have geometry still, but those you won't be able to walk over it or push it, or it won't be able to fall and land anywhere. It'll just pass through if you have physics simulated. So right there is a whole section for collisions. You see there's a bunch of simplified, some more complicated ones you can choose from. The very last one, autoconvex, makes a very complicated one. Sometimes it's necessary, especially if you're going to pick up complicated objects. But the very most simple scale or simple settings, you have boxes of geometry that are covered in boxes of collisions. And you can see there it's the purple lines that by default aren't visible in the scene. So there's a simple box. You can see it has the purple line, so it has collisions as well, and it behaves like you think it would. It's not set to simulate physics, right? Everything's turned off in game engines to begin with. So it would be on the details panel if I wanted to make it actually if I actually want to make it simulate physics. I was pulling out some boxes that are in part of my content browser already. I didn't want to mess around with the engine geometry, because if I wasn't sure if I deleted the collisions for like a basic cube inside of my engine, I might have deleted the collisions for every cube in all the projects. So you can easily repair an engine. In fact, it'll prompt you to if you start making changes to the engine. But see there, we've turned off collisions and now I can pass through it. And then we can simply add collisions back on. So that's a simplified cube, or we can do different shapes if we don't want the collisions don't have to follow the geometry shapes. So I'm removing it, and now I'm going to add on a sphere. And so if this was simulating physics and we pushed it or we dropped it, it would actually roll, even though the geometry looks like it's flat. And that's just like an absurd example just to prove a point. I get over the details panel, and then you just scroll down, and there's simulate physics, turning it on. The engine has already assigned things like mass to it, bounce. Those things can be overridden. There it fell, and then we give it a little oomph to make it roll. Unfortunately, I don't think you can preview collisions at runtime. It's not like trigger boxes, trigger cubes that we're going to get to in 1 second. So yeah, now we're going to talk about just hidden collisions, empty collisions. There's things called trigger boxes or box collisions. There's also other shapes as well. You see there, capsule, sphere. And you put these in the world, and they register overlap events. So have I walked into it, or have I walked out of it? This is how like all doors are done, right? You walk into an empty thing that says, oh, this person is in front of, or this character is in front of a door, let's open the door. So if inbox, open door. So that's like the pseudocode for what we're going to do. We're going to walk across this, and when we're inside, we're going to send out an event that will move the transform of a door or a cube, right? And moving the transforms are position, scale, and rotation. So we're going to be moving the position of these, and if you have like 2 sliding doors or 1 raising door, that's you move the transform over time once an event occurs. Or we can trigger anything. This is a level blueprint, all right, where you just want something to happen once. That context-sensitive button is, or checkbox is checked, meaning that these are all the things you can do with the object that is selected in my outliner, that being a trigger box. Right? So if I go to my level blueprint, I can right-click and I can see events right there for trigger box. So level blueprints are things that happen once. They happen, you just want to prototype them inside this level blueprint, and it's not going to be something repeated. If it's repeated, we might want to think of a more efficient way of doing this. But for right now, when you want to just test items, let's start with a level blueprint first. And everything there are events and functions that happen to be related to trigger boxes. The context-sensitive checkbox is filtering that list. And that list we took off the checkbox would be every single function in the entire engine. And it's all just searchable. So sometimes you can just kind of pseudocode into the search box and stumble upon the right things to do. So in the events, we're looking at for collision events, and as we're talking about, we want to do both an event for entering and leaving. So when you go into the box, the door opens or the thing turns on, and when you leave the box, the thing turns off. But first, let's just test and show what events look like inside of level blueprints. So clicking that brings up our first blueprint node. And blueprints, again, are a visual scripting language of node-based language. And there, the color signifies it's an event. Events are red. It does something. It triggers something. And then there's the white arrow, and that is a execution pen, and you connect execution pens to have functionality or interactivity. We're going to print something to the screen just to prove that the event is being triggered. This is like a debug methodology. You can use a bunch of print strings, and it can just verbosely tell you when things are working or not working. So I typed in a custom message. And trigger boxes, I think you can't show those at runtime, but box collisions are the same exact thing, but you can. Just something I've experienced from I do this a few times. So box collision, or I guess I'm doing it with trigger box too. Anyway, we're now setting it so you can see it during playtime, where it's no longer hidden in game. And this is again another debug setting for us. And boom, when we enter inside of it, or when we begin to enter inside of it, it's now printing to a string being a line of text. So Unreal is known for its beautiful lighting, and let's put it a point light, and let's do things with that light inside of a level blueprint based off of the event. So the event of overlap is right now printing a string. Well, let's do something to a light. So it's selected in the world outliner. We can bring in a reference to it, or we can just drag a reference in. Cool, so that's now, we're able to do things with a point light. And we drag off with context sensitive still selected. These are all the functions with lights. And we can change color. We can basically do anything with the light that is in the details panel of the light. All those different settings like intensity and color and fall off, the position, rotation, all those things can be changed in blueprints. And here we're working with visibility. So by typing in visibility, we can see we can either set the visibility or we can toggle visibility. It's on by default, and now we're toggling it off. Light goes on, light goes off, light goes on, light goes off. Right? Only when we're entering into the collision, though. So let's do the other one, which is when we end overlap, meaning we leave the cube. And that way they're working together to make a more logical functionality. You go and it's off, and then you leave it and it's back on. So let's work with setting visibility, absolutely, so that we always know, like toggling, we don't know what state it is in currently, and this is more of a hard coding it so that we always turn it off or on specific events. So new visibility would be on, and new visibility unchecked would be off. And then we can just put that audio component, or sorry, that light component into both of them. So it's on, it's off, it's on, and that makes more sense as interactivity. And as you can see, I can mouse wheel in and out and give more space. We can keep these things organized. Some people make them look quite nice and beautiful. There's websites dedicated to the unholy mess that you can turn blueprints into. If I highlight a bunch of nodes and hit the C button, it'll let me write a comment. And it's good practice to comment everything, especially if you're working with somebody else. You can color code things so you can easily see amongst a whole big pile of blueprints what is, if you come up with an idea of red means warning, needs work, green is all set. And what's cool about that is, as you just saw, if you click on the header, you can move all the nodes around together. So they're really encapsulated, like visually and functionally. And you can write more verbose notes. You know, you can leave little hidden breadcrumb trails for other programmers so that they know and they can help you out. And it's also for yourself. I mean, you come back to certain things you've done weeks before and you can't remember what you were trying to do in the first place. So let's look at some other functions we can do. When you're dealing with a lot of these parameters, you are either setting them, which is what we've been doing, right? We've been setting the parameter of visibility, but you can also get these parameters, right? So setting and forgetting. Sometimes you're you need to find out what the status is first. But right now we're going to set the light color, which is an RGB and A. That is a floating point number for each of those values being 0 to 1. Therefore, 0 is no red and 1 is all the red. And you do that for each channel. We don't need the visibility ones, just delete them. We can always bring them back. And then you see that black square there. If I double click on that, I get a color wheel. And there you go, on the left side you can see there's black, of course, is the absence of color, so 0 RGB, but the alpha is all the way at 1, meaning that when I do add a color, we'll be able to see it without transparency. So you can use the wheel, you can use the sliders, you can type in numbers, copy and paste hexadecimal code from websites and other applications. And now we're triggering a light color change. The blue is a little hard to see, so let's go ahead and do it with orange just to prove a point visually. There you go. So the event is firing and setting the color. But that we can also split up that RGB there by right-clicking on the blue circle and get these floating point numbers I was telling you about. And you can see what the number is there. It was orange is a value of, well, it's 1 of red, it's only some of green, and it's none of blue. So what's always fun to do with programming is just to generate random stuff, so it's a surprise for everyone. So we need to get a random number that's between 0 and 1. That would be with a decimal point, so like 0.5 or 0.25. If we got a random float, it would be like any random float, and anything above a 1 wouldn't really register, and we would be dealing with a bunch of numbers that we don't need. So we want to find a limit for it, so we want to find a specific range that we can type in. And there we can type in and hard code in 0 and 1. And then plug it in. And Control W on PC, Command W Mac, duplicates, or you can just hit the duplicate by right-clicking on the node, or you can copy and paste. And there we go. We want to change a random number between 0 and 1 for R and G and B, but we want to leave the alpha at 1 so that we're always able to see it. Endless fun. Now, this light is so cool, but I wish I had more of them. And you can see how copying and pasting it means we have to add events for each one of these triggers, and then hook up all these random nodes to each of these lights. And you can see how it can get quite complicated. We need to think about a better way of programming this. We need to make its own encapsulated object in Unity. This is called a prefab. Here in Unreal, it's called a blueprint actor, or a class blueprint. So it's a blueprint that we're going to make inside of our content browser that then we can drag out into the world, and we can drag out the world many, many times, and therefore we're not trying to program each thing one by one in a level blueprint. We're just programming it once, and then we can override settings, and it'll override settings for all of these items. So they're kind of connected in a certain way, and their functionality. So I keep everything organized, and I make a content, in my content browser I put an assets folder, and that keeps it separated from all the other content I'd bring in, like marketplace stuff, which would have its own folder structure. You can also always decide, if you're working with a bunch of people, if you want to have a bunch of different asset folder, and like be Todd's assets, or each person's assets. Inside my assets folder, I make folders for materials and textures and blueprints and everything that there is. I gave you guys a link to a style guide. The style guide is kind of like a rules that everyone agrees upon on how you want to name things and do folder structures. So there's already sample folder structures in that document that was on GitHub. So I'm right-clicking, and I'm creating a blueprint. And I'm just going to do a blueprint actor. It's the most simple one, and it's at the very top, and it has all the settings are allowed for you, but it doesn't have any specialized functionality. The style guide dictates that blueprints start with BP underscore, and then just give it a sensible name or a crazy name. It doesn't matter as long as everyone agrees on the name. We've got some ghosted out nodes there that we can talk about in just a second, but here's the layout of a blueprint actor. It has its own viewport because we're going to create it as a thing outside of the level. And then it has its own event graph for blueprints. And then on the left side, you can add components. Like in our case, those components are the box collision and the lights and whatever we're going to work with. On the bottom left will be variables, which we'll get more into soon. And that's our programming components that we're going to create. The details on the right. And but you can also build it by dragging it to the world and seeing how it looks in the world as well. So kind of like, this is when it's really good to have two monitors, but we can do it kind of side by side. So there it is. That circle right there is actually just a null. It's called a default scene root. It is not geometry. It's just something so we can find our blueprint. Right? It's just a little icon for us. We haven't really added in any components just yet. So I can try to show both at the same time, so that you can see in the world. And now when I add a component for lights and box collisions, it'll be added to the world as well. So there's a list of common ones at the very top, things we use the most, but there's quite a long list. There's, of course, a search field there for us to find things we're looking for. There's our collisions. Add them in and see it's been added to the viewport in the actor blueprint and also in the level, because that level is hosting, or it has the actor blueprint inside of it. And we also know that we want to deal with a light, so let's bring a light in there. And now it's under the ground, so we can move the whole blueprint up, or we could have just moved the light component up. And we can use the same code and then we need to hook up an execution pin. You can copy and paste blueprints between, blueprint nodes between blueprints like that. But it's actually a kind of markup language that you can put in. Here I'm going to make a snippet, a code snippet. You can paste in an email, so you can send these blueprints to each other and not have to worry about like using a screenshot and recreating it from scratch, or sending entire projects, just seeing each other's sections of code. And you can try with this. It's now in your Slack for week 2, and you copy paste it, and you have the code for changing random light color already. So we need to add in a collision event. Here in the blueprints, the actor blueprints, you right click on objects to get their events. And you can see there's our begin and end overlap. So now when we begin our overlap, we can go set the light color. We haven't told it what component we want to change. There's our point light component. Let's add it in, compile again, and then it's ready to go. I don't think I set the box collision to visible, but you'll be able to see the light, yeah. So there we go. And we haven't actually visually debugged a blueprint. You can actually see the event happen when you run around. So there it executes, right? So this is another way of telling, being able to debug whether or not your code is working. So anyone who's taken, JavaScript or done other languages, text-based coding languages, you know that there's a void setup and a void draw. There's a draw every frame, and then there's an event that happens right when you hit play. There's other events. There's awake and some other ones, but it's here. It's already there. We're waiting for you in case you want to see it, just like other kind of IDEs would have for their code. And then it has an overlap because, of course, as we were saying, overlaps are one of the most used ones. Like this is just an overlap for the general actor itself. But we can delete these if they're in the way. And there's our tick. The tick is the frame rate, right? So it's a tick every single frame of the game as it's running. And remember to save all. Now, if you hit the save button in the top left-ish, where it says save, it looks like a little old floppy disk. That only saves the object you have selected. Save all is actually a Command Shift S, I believe, or Control Shift S to save everything that's been changed. So I forgot to kind of show you the really cool part of having an actor blueprint is that once you have one, then you have many. This is called a blueprint class, and each actor is an object of that class. And you can select them all, move them, but you can also change the blueprint itself, and it'll propagate through. Here to make a bunch quicker, I am holding down Alt and dragging, and that duplicates everything that I've selected. So now I can make a rave. I have my little rave lights I can run through. There you go. It's working. They're a little bit too bright, so it's they're washing out the screen. But each one is randomly changing every time I pass through it. So yeah, it's just emphasizing that here's the details are for each component and the changes. So if I want to make these boxes visible, I should be able to find some sort of rendering thing there. It says visible or hidden game. And make sure it's not hidden in game. And that's changed all of them. Right, so it's super powerful, and it keeps you from having to do a lot of repetitive tasks. When I'm making games, or when people are making games, almost everything is an actor blueprint because everything has a game mechanic to it, right? And it has to be done a bunch of times. But when I do narratives, like for virtual reality, almost everything happens just once. So almost all of my narrative pieces are based off of just level blueprinting, just one-off things that happen on a timeline. Here to prove a point, I can move the light up, and all the lights are moved up. And just, there's a lot of settings for lights, so you can go through them and play with them to adjust them the way you want. Attenuation is fall off, right? That's like the distance around it that the light is emitting to. Intensity is, has some caps on it so you don't get it too bright, but, now it's really blown out and you really can't see any colors. It's called bloom. And now I can see again. We'll turn the light back the way it was. All right, great. You gotta give him a little bit more intensity, I think. There we go. Now we can see him. Back as we were. Cool. Field of rave lights. So now we're going to do some different interactivity. We're going to work with the transform, which is, again, a transform is a combination of location, scale, and rotation. So maybe we can make a door so that when we get in front of it, it'll open up the door. And then when we go through it, it'll then close the door behind us. Here's some simple geometry. I'll try to make this as simple as possible and not get into too many details, just to, again, make a proof of concept. So I'm thinking totally of Star Trek doors right now that open, they make a little noise when you go through them. And snapping is on, so they're perfectly aligned. I'm going to do this in my level blueprint first because I'm prototyping it. You don't have to prototype in a level blueprint, but it is a common workflow. And I'm making sure the trigger box isn't overlapping with anything else, like the floor or the doors themselves. You might see other little circles on those event nodes in the blueprints, and you can always drill down that only when a certain actor overlaps does that event happen, but we're keeping it as simple as possible so our trigger boxes have no overlaps to begin with. So with the trigger box selected, let's bring in the event for overlap and ending overlap. And remember, the end overlap can never happen unless the begin has happened first. So there isn't, if I hit play, it doesn't trigger an end overlap. So I think the idea, so we're going to rename the cubes so they have a more meaningful name, but also I think it might be a little more complicated to do two doors. It's a lot of redundant programming, so we might simplify that. But I can bring a reference in for both of them, and if I delete one out of the world, it'll delete the name out of the actor blueprint or the level blueprint. Now we're going to get a timeline. A timeline is kind of just like in Premiere, After Effects. It's going to be it's a value over time. I'm just going to give it a name, and then you see it has all those execution pins that can happen. You can play it, you can reverse it, and we're going to get those overlap execution pins into play for when we're going to play the animation to open. And then we're going to reverse the animation so that we're keeping it more simplified. Just undo or reverse playback the thing that already played back instead of using two timelines, which would be a waste of space. So we're going to do this with decimal points, which is a floating point number. So we're going to bring in a float track, which is that F on the left. What are the other settings we see here? We see that the length by default is 5 seconds, so it would be very slow door. You see that we can have an auto play, so it's not just when we overlap, it's like event begin play, or it can be a looping thing. Once we trigger it, it just keeps on going and never stops. We could scroll out and we see, again, this is over time, there's a value. And by default, that lighter area is 5 seconds. So we're going to right click and add a key. And you see now that we can see a time and a value for that key. And it's going to start at 0 time and 0 value. So start at the beginning where you are. And let's add a second key in. And we'll go ahead and put this at 5 seconds. And we'll just make it a value of 1. We can multiply it by a number to make it larger, because I think the Unreal units are a centimeter, so we'd barely see it move. So it gave me a warning. I deleted one of the doors. It just let me know that it's the door is being referenced in a level blueprint. And if I do go back to the level blueprint, I'll see that there's an unknown or an empty node, that I can just delete and get rid of. Okay, so when we execute it, we're going to play that 0 to 1, and then we leave. We'll reverse it to go back from 1 to 0. And then there's the value that comes out of it when I named that track open and then added that green circle there. And so let's drag off the door, and we want to set location. We could set the whole transform, but that's a bunch of wasted space because we're not going to scale it, we're not going to rotate it. So we're just going to look for setting location. Here we go. It has an execution pin, and it has X, Y, and Z. Just like the color, where we separate it out by right-clicking on it and saying split it up, since we don't care about moving it laterally, we only want to go up and down. We only want to affect Z. And yes, I know it's weird to have Z be the up and down axis. That is just what it is in Unreal, so we have to get used to that. So you split it up, and then you can address X, Y, and Z. So we'd plug that into Z. We want to go up and down. But what this is doing is also hard coding in a value of 0 for X and Y. And our object, our door, is not at X and Y, so we'll see what that does. You can kind of see the transform on the right. You see these objects aren't at a certain location. I mean, they are at specific locations. So we're going to override those transforms when we hit these overlaps. And also, again, as we're talking about, game engines are lazy. Everything is set not to be movable at first, or a lot of things are set not to be movable. And so you make sure that this is movable. It won't error. It'll give us a warning and tell us that we should be doing that. So that's a good reminder. Here's where I'm putting it down at 0 just so we know where it is to start off with. And make it so we can see our trigger box. We walk over there, and then where does it go? It's executing. See, we got the warning because we hadn't set it to movable. So yes, we want the game engine to be polling for whether or not it's being moved. We want to allocate resources to moving this actor, so now we shouldn't get that warning. Also, we really wouldn't be able to see it just moving 1 centimeter, so we're going to increase the amount it moves up. We could have used a variable to multiply it, but this is straightforward. So where does it go? Well, now that it's movable, I can kind of see it in the distance. Can you? I'll do it again. Play, go over, and then it goes over to 0, 0 because we hard coded those values in there. It's good to see that the end overlap works. That's good news. We just need to get those position values correct. So, like I said before, we can set values, but we can also get values. So let's go ahead and grab the values for X and Y and plug them in. That way we don't have to hard code things. We can just reference where it already exists. It's the simplest way of doing it. So now it should stay in place, except for moving it up and down. That is the expected behavior. It's not the greatest door, but it's the expected behavior of this door. And now let's go to the rave and go back to the door. So now we've done a simple, straightforward animation. Right, and some, everything can be addressed in these blueprints. Every one of these checkboxes, every one of these values has a blueprint node associated to it that you can drive with overlaps and on the tick and at the Vim play. And we can even, set something to simulate physics when you get closer to it. So we'll do that next. So let's clear some space, and we'll let this cube with a sphere collision, simulate physics when we get close to it. We'll move it so it's not overlapping anything to begin with. And so let's bring our reference to it into our level blueprint. See, it's selecting the outliner. So context sensitive, we'll bring it out. We can give it a new name if we want. Add our event. Bring a reference to the cube. Drag it in. And we want to do something with physics or simulation, so we can search for different words and see which one brings back the ones we want. It's a lot to read there, so maybe we want to call it something else. And there we see we can get, is it simulating already? Therefore we can add like a little conditional based off of is it or not. Or we can just override it and say, no matter what you're doing, I want you to simulate physics when I execute this pin, which is the checkbox. We make sure it's checkbox to be simulating. At the beginning, it will not be simulating. Keep it in its own little comment box, chunked together. And let's go for it. And then it fell. And we can push it. It works. All right. Cool, so now I can save and we can do version control. I'm going to go ahead and go to the root folder. I'm going to commit. Once I'm done committing, I can put a note, right? I have a few things that blue means they've changed, black means they've been added. I can select all to be updated or just a few things. So if you make some changes, you don't have to update all of them to the repo. You can keep some local only. And then we need to write some notes to ourselves and to others who are sharing our repository. You see that it tries to autocomplete with asset names. So we added some blueprint assets. We added we messed around with some collisions and changed a certain level, and we can give the name of the level, just so everyone knows a list of everything that has been done. And then we say okay, and now it's pushing it to my cloud storage, and depending on the network, as how the network speed determines how fast it uploads. And then we're at revision 3. The first one was me making the repo. The second one was me doing the initial commit last time, and then this time it's me doing these changes, that small list. And I did it from the root folder, so all of them have been added. I could just do it from specific folders if I wanted some subfolders to be uploaded.